All right, welcome. Today, we're diving into a pretty massive challenge. How do you design one single global application that runs across the three biggest clouds out there, AWS, Azure, and GCP, all at the same time? Let's jump right in. So imagine this lands on your desk. It's a huge ask, right? We're not just talking about using multiple clouds. We're talking about weaving them all together into one single seamless system. The complexity is just off the charts, but the potential for resilience and performance, even bigger. This is the high-stakes world of the multi-cloud architect. And here it is, the core request, straight from our source material. Now, that sentence sounds deceptively simple, but it forces us to answer some of the absolute toughest questions in modern infrastructure. I mean, how do you handle users, data, and networking when your very foundation is split across three competing companies? So to figure this out, we're going to deconstruct this massive problem into four key architectural pillars. Let's start with the first and, maybe the most fundamental decision of all, the footprint. And that brings us to our first pillar, the footprint. Seriously, before a single line of code gets written, we have to decide where in the world our application is physically going to live to best serve our users everywhere. So here's the central question for this pillar. With users all over the planet, how do you guarantee a great experience for someone in Tokyo and someone in London and someone in São Paulo all at the same time? Especially when your infrastructure is split across AWS, Azure, and GCP. The solution is a really powerful strategy, an active deployment. Now, what's so cool about this is the principle behind it. We intentionally pick regions where all three providers have a huge presence. Think places like the US East Coast, Western Europe, and Southeast Asia. This means if a user is in Germany, our system can route them to the absolute fastest server, whether it happens to be on Azure or AWS, and they will never know the difference. It's pretty much the ultimate setup for availability and speed. Okay, let's move on to our second pillar, identity. Once we know where our application lives, we've got to manage who gets in. This is like the universal key to our entire system, and it has to work flawlessly across all three clouds. And this really boils it all down. Just think about it for a second. An administrator at your company needs to manage resources in AWS, deploy code in GCP, and check logs in Azure. Are they supposed to have three different passwords, three different sets of permissions? No way. That would be a complete security nightmare. The answer is to centralize and then federate. In step one, you pick one provider as your source of truth. A lot of times this is going to be Azure Active Directory, mainly because so many companies already use it for their corporate logins. Then step two is where the magic happens. You use open standards like SAML to link or federate that single identity out to AWS and GCP. This unifies your access control, which means you manage permissions in one spot and they're enforced everywhere. It's simple, it's clean, and it's way more secure. Okay, on to our third pillar, and you could argue it's the most complex one, data. Data has gravity. It's hard to move, it's subject to all sorts of local laws, and just keeping it consistent across the entire globe is a massive challenge. Let's see how our architect solves this puzzle. So here's the core problem. You've got a user in France, and their data needs to stay inside the EU to comply with GDPR. But they also need access to shared global information. And at the exact same time, a user in Australia needs super fast access, which means their primary data should be stored nearby. How in the world do you balance all of these competing needs? Well, you do it with a hybrid strategy. This slide shows the two-part solution perfectly. First, you create what are called regional data pods. This means a European user's personal data lives exclusively in the European region. Boom, data sovereignty laws are satisfied. Second, for all the common data that everyone needs, things like product catalogs or config settings, you use global replication to copy it everywhere for the best possible performance. It's really the best of both worlds. And this brings us to our final pillar, networking. If the clouds are different cities, then networking is the superhighway that connects them all. It's the glue that makes our distributed application actually feel like one single system. The goal is to connect the private networks within each provider. AWS and GCP call them VPCs, Azure calls them VNets, so they can all talk to each other like they're on the same local network. This connection has to be fast, it has to be reliable, and it absolutely has to be secure. The architecture here is a classic hub and spoke model. For step one, you establish these private, high-speed connections to each cloud. Then, for step two, in each geographic region, you set up a central networking hub.
This hub is like a traffic controller directing all the data flowing between the different clouds. And finally, you have a global DNS layer sitting on top of the whole thing, intelligently sending users to the nearest and healthiest location for.
So we've walked through all 4 pillars. Now let's zoom out and put it all together. What were the absolutely critical design decisions that made this whole blueprint work? This slide right here, this is the secret sauce. First, by using container tech like Kubernetes, we abstract the cloud, which lets our application run anywhere. Second, we federate identity, so there's only one source of truth for security. Our hybrid data model brilliantly balances global speed with local laws. And finally, that hub-and-spoke network elegantly connects everything. These 4 decisions are the absolute heart of a successful tri-cloud architecture. And that brings us to a final, pretty big thought. This kind of architecture changes how we think about the cloud. It's not about choosing AWS or Azure or GCP anymore. It's about using them all as part of a single global computing fabric. This opens up a whole new world of possibilities and new challenges for the next generation of applications. So the real question is, what are you going to build on this new digital continent?